Okay, we are going through this topic. We have covered volume variations and intersection volume studies. And then we have moved on to network volume studies. And what network volume studies are of two types. We have limited network and then we have statewide program. We already covered limited network with some examples. And the last thing we were doing was discussing the rules related to statewide program. Already explained the guidelines. Okay. We have used adjustment factors even in the limited network studies as well. Or face recognition. You are wearing mask, that's why. Okay. So whenever we have 1 day of data and we want an average, we were using the adjustment factor. Okay. The same will apply to statewide program. Okay. But the average which we are looking for, who did the average we are looking for is the yearly average. Okay. And what do we call the yearly average of traffic? What do we call it? Yearly average of traffic. They're the term which we used. Huh? None. Average annual daily traffic, yes. That should be true, right? Anyways, but in the statewide program, our aim is to always go for the average annual daily traffic. Okay. So these adjustment factors or whatever factors we will discuss are related to calculating AADT, average annual daily traffic. Okay. So in a statewide program, on one of the points, this is data from one of the points. What they did, they took the volume of the entire year, 365 days. From that volume, they separated the Mondays and Tuesdays and Wednesdays and so on. Okay. So every day was separated from that data. And for every day, they calculated a separate average. And these are the average values you see, which you see in this table. Okay. Average for Monday and Tuesday and Wednesday. Okay. So they are coming from the whole year of data. Okay. So they separated the values into each day, and for each day, they calculated its own average. Clear? Clear? Okay. Now this is a statewide program. So which average do I really want? These? Do I want these? Which average do I want? Average of each day? Huh? Yearly average, right? Okay. So first thing is I will calculate the yearly average. Okay. I have 7 values which belong to different days of the year. I will take their average to give me the yearly average. Make sense? Okay. Clear or not? Okay. For each day, the average is already taken from the whole year. So now I can do the average of these 7 values and call it the yearly average. Got my point? Okay. You cannot go back to the previous examples and say, okay, I have 7 days of data. I'll take that average. This will become yearly average. No. This is average of 7 days. Okay. There's already an average of 7 days. So this is the average of Monday. This is the average of Tuesday and so on. Okay. So now I can take that average and it will become the yearly average. Okay. So first of all, what is the yearly average now? Tell me. So we are calling it the AADT, right? How much? 1430 vehicles per day. You guys are done with attendance? Huh? I'm asking for the girls. You're gone. Okay. Now, the question is not about calculating the yearly average. The question is about calculating factors, adjustment factor for each day of the week. Okay. For the adjustment factor, we will use the same equation which we have used for limited network study, which was the traffic of the day upon the average. Okay. So if I want the adjustment factor of Monday, I will take the traffic of Monday divided by the average. Okay. So so for Monday, it will be 1820 divided by 1430, which is how much? 1.27. Okay. For Tuesday, it will be this upon what? 1430. Okay. The average remains the same. Clear or not? Any questions? Any problem? Okay. And I told you a check for these adjustment factors. What was the check? Anybody remembers? You calculate all the adjustment factors and then how can you check them if they are correct or not? Huh? No, that was expansion factors. Some of them have to be more than one, some of them have to be less than one. And there was an intelligent guy who didn't come today. He said the average should be one. Okay. So anyways, I'm not sure about the average. I didn't try it, but it makes sense. Okay. But obviously some of them more than one, some of them are less than one. The average will be very close to one. Even if it is not exactly one, it will be very close to one. So we are getting an average of 2 and 3, then that means there's a problem. Okay, any problem with this one? Clear? Okay. Now this is the plot of these adjustment factors. Now remember, adjustment factors were traffic of the day divided by average. Okay. So when the traffic increases for this day, the adjustment factor will do what? It will increase. I think I made a mistake. Yeah. Could be the other way around. It was this. Sorry. How much is this? 0.79. Okay, this is the equation. The average should be on the top and the daily traffic is in the denominator. Okay, this is the actual. Everybody done? Now see, he will not say anything. Okay, average should be on the top. Now, if the traffic increases, the traffic of this day increases, the factor will decrease. Okay, so this is the same thing which you see in this graph. The factor is highest for Saturday. That means traffic is lowest. Clear? Okay. Then we have another example in which we are calculating monthly adjustment factors. Okay, now the data is slightly different. In this data, they have provided total traffic for each month. Okay, they have given us total traffic of each month. Total, not average. Okay, so I'm going for the average, right? Total does not do anything to me. Okay, it does not mean anything to me. The first thing is I will calculate average for each month. Got it? I calculate average of each month. Total is given. I calculate the average. Simple. You divide by what? Number of days. So for January, it will be 19840 divided by how many days? 31. So how much? Clear? February? 20. Clear or not? Any problem? Any question? Okay. I told you what we are going after. What is my main aim? What is the last thing I want to calculate? Which average? ALD. Okay. So how do I calculate the ALD average? I still need these numbers. Okay, I'll get to it. But how do I calculate the ALD average in this case? I did it in the last example, right? All the values divided by 7. It was 7 days. Now what? Divide by 12. Divide by 12. There's a difference in this example and the previous one, right? Huh? The previous example, everybody doing this. Okay, what was the difference? Okay, and another one. If this was the only difference, dividing by 12 will work. If this was the only difference between the previous example and this example, days and months, dividing by 12 will work. Like dividing by 7 worked there. But here, the value is different. It is by month, but it is total. Okay, it is total. That's why you are dividing by the number of days, right? Did you divide by number of days in the previous example? No, for each value you didn't, because it was already an average. These are already an average. Yes, these are totals. Okay, so dividing by 12 will not work. You will do the total and divide by how many days? 365. Okay, so give me the total traffic or AADT direct. So the total of this whole thing divided by 365 will be your AADT. Everybody gets the difference, right? If it was already an average, the previous example, already an average. Okay, I just divide the number with the number of values I have. Here, it's not an average, it's a total. Okay, so for each value, I have to divide by the number of days in which it is taken. So the January value is taken for 31 days. Yes.
Here, when we calculate the average, can we?
can. Yes, we can. Okay, but and the value should be very close. If you took the average of each month, like we were doing for 2 months, we did, right? So you did it for all the 12 months, and then you took those averages divided by 12. This will also give you AD. Okay, and the value which I will get like this and like this should be very close. Okay, they may not be exactly same. Okay, we call it rounding off types. By statisticians, they say that no, this is difference because of your method. Okay, if you take the average of averages, if you take the direct average, there will be difference. Okay, so they consider this method to be more accurate. This method is more accurate. So if the data is given, we will go for the first method, the one which we are doing now. In the last example, data was not given. Okay, so yes. ADT, how much is ADT? Yes. Okay, total traffic upon total number of days. If I have this, I will go for this method. It's more accurate. But if somebody gave me the data like the previous example, obviously I will take the number of values divided by the number, obviously. I don't have any other way. Now, if I want the adjustment factor for January, the average of January is 640. The average of the whole year is 797. How do I get the adjustment factor? Sorry. No, the other way, corrected in the previous example, right? The average is on the top. Okay, so 797 divided by 640. 1.25. Okay, for February will be 797 divided by 595, which is 1.34. Clear?
The graph we have different. See the graph.
Which graph?
Next slide.
Is this clear? Is this clear? Any questions? Yes.
It's 1.1.
1.1.
We got 1.25.
She got 1.1.
Maybe the AADT is wrong.
Maybe the ADT is wrong. Maybe the factors are wrong. Maybe the monthly average is wrong. Maybe what I'm saying is wrong.
Maybe it was not finished.
For what?
And now-
If I don't know what is wrong, how can I cut your marks? Yesterday, some people came from the other course for their copies and they said she made the same mistake and you gave her more marks than me. Nobody is interested in what is a mistake. What is this now?
That was great.
What happened to it?
Didn't answer.
Quiz grade?
Yes.
You mean to post it? I will post it, no problem. It will not change. Okay, got it. Okay, the question is clear. The problem which we did is clear. Okay. Now I told you we have three types of control counts in the statewide program. Statewide program has three types of control counts. One is a permanent. Previous two examples were from those counts because we had the data for all months and all days of the week. Okay, so it was permanent. The detector or sensor is there 365 days of the year. Okay, so you have complete data. You can calculate average of each day, average of each month, full year average, whatever. Okay, but we have two other types of control counts as well, which are taken for less than 1 year. Okay, so this is the data from one of those locations. So data is not continuous here. You can see. I don't have the data of the full year. Okay, so you can see in the first table. So there were two different teams, or maybe they were doing it two different contractors or two different departments, government departments. They collected data differently. Okay, in the end, we got two data sets. The first one is the data of 4 weeks from the whole year. The 1 week in January, one in April, and so on. Okay. And for this team or for this data set, I have the value for each day. You can see it here. In each week, all 7 values are mentioned. Okay. Then I have another data set which is from the second team or the second department or whatever. This is 12 weeks of the year, meaning 1 week in every month. But the data is not day wise. The data is what? Average. So this is the average of January week. Okay, the average of those 7 values. Clear? Okay. Now we have to calculate the monthly adjustment factors and daily adjustment factors, both. Okay, because we have the data which belongs to different days and we have the data which belongs to different months. Okay. Again, the first thing we will do is calculate AD. Okay. In the previous example, what you are doing, if the values were already average, I take the values, divide by the number. If the values were total, I take the total, divide by the total number of days, right? Here is a mix. Okay. So if I'm taking the values from the first table, it's for each day, right? Okay. So how many days in total? No, total. 28, right? 74, 28. People are thinking, oh, it's 74, it's 28. It has been for many, many years. Okay, so 28 days in the first table, right? What about the second one? 12? 12 data sets, right? Okay. If I want to combine them, they should be in the same units, right? These are day wise, and this is an average, right? Okay, so if I want to combine them, they should be in the same units, right? I cannot combine 1 day value with an average. Okay, now I can calculate the total here, right? I can calculate the total. Okay, this is an average. How do you convert average to total? How do you convert an average value to total? Sorry. Multiply by the number, right? Average is divided by the total, right? Divide by the number. How do you calculate average? Total by number, right? So if you have total, you want, you have average, you want total, you will multiply by the number. Okay. How many numbers? How much is the number of days here?
7.
7, right? So if I multiply this value with 7, it will become the total of the week, right? Okay. So if I add these values, it will become total of these 4 weeks. And if I multiply each of these values with the 7, it will become the total of each week, right? Clear or not? Any questions? Okay. So after multiply by 7, they are total. They are days value. No, nothing is average now. Okay. So I can simply add them together. Clear? Okay. So I will take all the values from this table. Simple addition. Okay. For the values from this table, I will take them and multiply with 7. So this is for each day, and this will become the total of the week. So I will add them together and divide by 112. What is 112?
84 plus
Hmm?
84 plus 28.
28 is the number of days in the first table, right? And what is 84? Yeah. We have 12 months, and for each month, 7 days. Okay. So table 1 has 28 days of data. Table 2 has 7 days of data from 12 months, which comes out to be 84. Total is okay. This is how I got 112. Clear or not? Anyone has any questions? Clear? Okay. Yes, we can do this. Yes. Like I told you in the previous example, you can calculate the averages yourself and then take the average of the average like we did earlier. Problem. Okay. But I told you the more accurate method is you keep the total as total. Okay. So what is my AADT? You take all these values, add them together, plus all these values multiply by 7, then add. How much? What?
I calculate the remote let's multiply by 7. 7 Take down.
Okay. This is close to the right answer, or you may have small difference in the fractions, but we can move on. Now, the next thing we will do is calculate the average for each day. Okay, calculate the average for each day of the week. Sorry, we will. Yes. So we will start with the average of each day. Which data set can give me the average of each day? The first one. Second one, I don't know how much is on Monday, how much is on Tuesday. So there is no question. You cannot use the second data set for calculating average for each day. You cannot. Okay. So average of each day, you have how many values for Monday? You have 4 values. Okay. Average of these 4 values will be the average of Monday. Average of these 4 values will be the average of Tuesday. Got it? Clear? Okay. Give me the average of Monday. What? Average of these 4 days will give you the average of Monday. Average of these 4 days will give you the average of Tuesday. Okay, where is Monday? Tell me. Huh? 1 month is 4. This is average of 1 week. But even if it was the average of the whole month, how can you separate 4 Mondays from it? Eventually, it's average. Okay, so from average, I can calculate total. I cannot separate it into different values. Okay. Okay, what is the average of Monday? 1925. And what is the average for Tuesday? 2100. Anybody has any problem with this? Any question, any problem? Yes. You will continue, okay? For each day, you will take the average of these 4 values. Okay. Now, if I want to calculate the average of each month, which table will I use? Second one, why not the first one? Because not all the months are there, but the months which are there, I know which months are there, right? So I can use it. I cannot use it for all the months, yes, but I can use it. Okay. So, for example, January. Okay. For January, I have data from here and data from the first table as well, right? So I want to combine them. I did combination here, right? What did I do? I took the values from here each day, and I took the value from there as well. And then I did what? Multiply by 7. So I will do the same thing for January now. Only for January. So I'll take the total of January from here. I will take the average of January from here, multiply by 7. Okay, so I'll take it from table 1, complete. Plus 7 times table 2. Divide by how many? How many days? 40. By 30. So you are saying 30 or 30? Both are wrong, obviously. But 14 days. 7 days of data from the first. These are 7 values, right? 7 values. And this is an average of 7 values. So 7 plus 7, 14 days. How much is that? Yeah, how much is this?
2030.
2030. 33. 3. 3233. No problem. Whatever. No problem. Okay, what about February? What we will do for February? Okay. Can I take any value of February from here? No. I'll take the value for February from here. Okay. So this is the value. Should I do anything with this value? No, because it's already an average. Okay, so you cannot take an average of the average. You cannot take average of an average. Got it? Will you keep it in your mind till the exam? Inshallah. Okay. So for February, it will be 2200. Okay. Then same for April. Again, April doesn't have a value. Okay. Yeah, sorry, same for March. Same for March. Then April, you will follow the same method as January. You take the total from here, take the value from here, multiply by 7. Clear? Clear? Any questions? Okay. Now for the adjustment factor, what are we doing for the adjustment factor? What divided by what? ADT divided by the average of the day or the month. Okay. In this case, we can calculate both because we are calculating monthly averages as well as daily averages. Okay. So if I want I believe the values are there. Yes. Okay. So how did I get this value? 1.02. It was ADT. Divided by 1925, this is average of Monday. Okay. For January, it was 1958 divided by average of January. For February, it will be 1958 divided by the average of February, which is already given. Clear? Anyone, any problem? Okay. You can go on along with this and later on check your answers. Okay. But the main thing was we were calculating the adjustment factors. In all the previous 3 examples, we are interested in calculating the adjustment factors. Okay. We are doing it for the statewide program. State means the whole country. And you can imagine the road network you will have for the entire country. It will be many, many points, right? It will be many, many points. And this calculation, which we did, and each example is for each point. A different point will have new adjustment factors, right? Because it will have its own traffic. Okay. So if I have 1000 points, I can have 1000 sets of factors, not 1000 factors. 1000 sets of factors, because each set will have 7 days and 12 months, right? Okay, so you can imagine how much data you will have. Okay, and more data means then you can have the analysis later on can be complicated. Okay, if I can merge some of the factors together, okay, my data set will become less and my analysis will become simpler. Agreed? Okay, so this is called as grouping of control locations, where you are trying to see the different sets if they can be merged or not. Grouping means I want to merge them together. Clear? Okay. Now merging means what? I will take a combined average for them. Merging means instead of having factor from location 1 and factor from location 2, I'll use their average. Okay, this is what merging means here. Okay. There. Now, if I take an average of a point, which is a factor of 2, and with the other point, which has a factor of 0.5, you can see the difference is too large, right? So this merging will not work because you are destroying the data. In the end, you will get what? 1 point something. This 1 point something is not close to 2, is not close to 0.5 as well. Okay, so your average is basically a very has a very large variation from the actual value. So we want to merge the points together which are close to each other. Okay, so for example, you have value 2 and 1.95. If you merge them together, you are close to both values, right? If you take an average, you are close to 2 and you are close to 1.95 as well. Okay, so we want to only take those averages which do not take us far from the actual values. Okay, if it is taking us too far from the actual value, we will not do the merging. Got it? Clear? Okay. Now, the rule of merging is the rule. How do we decide? Should we merge or not? Are we too far from the actual value or are we close? Can I take an average or should I not take the average? The rule is after taking the average, the difference of the average and the value of the average. So you took, for example, 3 values. So this average is of 3, right? Okay. So the value of the average and these 3 values, their difference should not be more than 0.1. The difference of the average and the values which you took for the average, their difference should not be more than 0.1. Okay. If it is, average is not possible. Okay. Throw it out. Clear or not? Okay. If it is within the 0.1 range, that means these 3 values, their merging with average is possible. Okay, it's valid. Clear? Let me show you an example. We have 4 locations. Okay. Each location, you can see the factors. How do we calculate these factors? I already showed you from examples. Okay. In the previous examples, we calculate these factors ourselves. Okay. So you do this for multiple points, you have a set of factors. Okay. The last column gives you the average for each day for these 4 locations. Okay. So 1.01 is the average of these 4. 1.02 is the average of these 4 and so on. Clear? Okay. Now what was the rule? The difference between the average and the value should not be more than 0.1. Okay. So if I look at this value 1.01 and this value 1.05. Okay. The difference is less than 0.1, right? It's 0.0 something. This one and this one less, right? This one and this one again less, 0.0 something. Okay. This and this 0.09, right? Okay. So for this day, I meet the criteria. Okay. Clear now? Take Tuesday 1.02. Okay. 1.02, 1.1, no problem. 02, 02, no problem. 02, 06, no problem. 02 and 0.89. Problem, right? So this does not meet the criteria. Got it? Okay. 06, 01, 06, 05, 06, 11, 06, 97. None of them has a problem. Okay, all of them are meeting the rule. This one, again, values are very close. Okay, all of them are 0.0 something. This one, no problem. This one, 0.98, 0.85. There's a problem. No problem here, no problem here. Big problem here. Okay. This one, no, nothing. Clear, right? This one is also clear. This one, clear, right? Okay. This one, there's a problem. Okay, clear? So we have identified 4 values which are not meeting the criteria. Okay. 1, 2, 3, and this one. Okay, so in the whole data set, there are 4 values which are not meeting the criteria. Okay, when this happens, okay, the merging of these 4 is not possible. The merging of these 4 locations is not possible. Okay, even if one value was not meeting the criteria. Got it? So when I reached here and I found that this value is not meeting the criteria, it leads me to the conclusion that these 4 locations cannot be merged. Got it? Okay. With one value, it is enough to make this conclusion. It is enough to reach to this decision that these 4 locations cannot be merged. Okay. So why did we check the other values? The reason is we want to see if I can merge 3 locations. Okay, if I can merge 3 locations together, if not 4, then I can at least try to merge 3 locations together. Sorry. Yes, we will. Okay, so now I need to decide if 4 cannot be merged, then which 3 can be merged together, which 3 I can try to merge together. That's why we did the entire exercise. That's why we checked all the values. Okay, so I have 4 values not meeting the criteria. This one, this one, this one, and this one. Okay, now you see this, this, and this. 3 out of 4, they belong to station. So if I remove station 4, it will solve most of my problems. Okay, so the remaining values are already very close. Okay, so I can try if to merge these 3 now. 1, 2, and 3. Got it? Clear? Okay, but obviously I cannot just decide, okay, let's merge 3. I have to check it again. Okay, so give me the average of these 3 locations, 1, 2, and 3. How much? 1.04. Okay. This one. Remember, that's the first 3. 1 point. 1 point. Okay, give me Saturday. Okay. Now we should calculate all the averages. By the way, we need all the averages. We are merging so that we can work with the averages. So in the end, if you decide with 3 locations to merge, you will calculate the average of all the days for those 3 locations. Okay. But why did I jump to Saturday after Tuesday? Now I'm doing this for checking, right? I'm trying to check if 3 locations can be merged together. Okay. So now I will check the problem areas. Where were the problem areas? There was a problem in Tuesday. There was a problem on Saturday, and there was a problem on Sunday as well. Okay. Okay. Give me the average of Sunday as well. How much is the average of Sunday? 0.86. Okay. The remaining days do not have a problem. Okay. For checking, I don't need the remaining days. For analysis later on, I will need it. We should complete the average for all the days. Now Tuesday, 1.06. Okay. Now we will check with the first 3 locations only. Okay. 06 and 10, no problem. 02 and 06, no problem. 06 and 06, no problem. Okay. So this problem is solved. Saturday. Okay. Now here was a problem with both the locations, right? I took 4 out. So there's no problem. Only problem could be here. Okay. Is this problem solved? 0.85 and 0.9. It is solved. Okay. For Sunday, where was the problem? Location? 4. I took 4 out. So there shouldn't be any problem. Clear or not? Okay. So locations and days which did not have any problem earlier should not have a problem now as well. Okay. When you do one trial and you take one location out, your valid values should increase. The values which are following the rule should increase. They should not decrease. So I had 4 values earlier which did not have any, which had a problem. Okay. So after taking location 4 out, I'm only left with one value which had a problem, which is 0.85. So if any other value is creating a problem now, that means these averages are not correct. Got it? Okay. Clear or not? Yes. Any questions? Okay. Now, these factors and their grouping is done for control count locations. Okay. So we have control count locations and we have coverage count locations. Control counts data is taken for multiple days and multiple months. So I can calculate ADT, I can calculate the factors and so on. Okay. Where do I take these factors? Where do I use them? I use them on coverage locations. These factors are used for coverage locations. So they are the location on which I take more data and calculate these factors. And there's another location in the same network, in the same area. Okay. You cannot take a factor from, for example, a local street in Muharrak and try to apply it on an arterial, which is in Saudi. Okay. So they should be on the same highway and the same type of highway and same area. Okay. So I have calculated factors in that particular area for a specific type of highway. In the same area on the same type of highway, I have another point where I have taken data for only 1 day. Okay. Can it give me an average of the whole year? No. Okay. So this is where I will use the factors from the other location. Okay. But you have to keep in mind that other location should be in the same area, same type of highway. Or you cannot mix and match. Okay. So how do I use it? So I have data which is taken only for 24 hours on one of the locations. In the same network, in the same area, I have these factors available from some other control count. So multiplying the factors with that 1 day will make it an yearly average. Okay. So if I have control count at one location and at 50 other locations, I just took the data for 1 day. So for those 50 locations, I can use the factors to calculate ADT. Okay. So this is where the factors will be used. For example, look at this. From a control count, adjustment factors for each day are calculated. Adjustment factors for each month are calculated. in the same area on the same type of highway, another point count is done on a Tuesday in July. Okay, so this is only 1 day value. I cannot call it ADT. But if I multiply this with the factor of Tuesday and with the factor of July, it becomes ADT. Okay, so for example, 1000 will be multiplied by the factor of Tuesday, which is 1.121, multiplied with the factor of July, which is 0.913. How much is that? Vehicles per day, and this is my AADT for the new location, the location on which only data was taken for 1 day. Clear? Any questions? Okay. Okay. Factors, same as the previous one. Now the data is for 6 locations, not 1 location, 6 locations. Okay. On each location, the day in which the data is taken is given, the month in which the data is taken is given. Okay. And they also give me the length. Okay. The length of this segment. Clear or not? Okay. What they're asking for is VMT of the year, 365 days. VMT means what? What is the meaning of VMT? Volume. And M for Muhammad, right? T for Tahir. And we're going into there. Okay. What does it look like? What does it look like?
Mile.
Vehicles and miles. Yes. Vehicle miles traveled. Okay. VMT is vehicle miles traveled. Okay. This 365 is because I want it for the whole year. Okay. But it can be for 1 hour. It can be for 2 hours, 1 week, 1 month. Okay. So this 365 is something which can change. But these two are there. Okay. So for example, I want the VMT of 1 year at this location, station 1. Okay. So first thing I need is what? AADT. How do I calculate AADT? Is this my AADT? No, because this is only 124 hour. Okay. How do I convert it to AADT? 9120. What should I do with it? 1.08, which is what?
1.1.
Sorry. Wednesday factor, right? Because the traffic is taken on Wednesday and multiply by what? 1.1, which is the factor for March. Got it? Okay. This will convert it to ADT. Okay. So this whole thing is your ADT. Then multiply by length. Then multiply by 365 because I want it for 1 year. If you don't multiply by 365, it will remain for 1 day. Okay. If you don't multiply with the factors, it will also remain for 1 day. So if I only do 9120 multiply by length 3, it will also be for 1 day. Okay. But which day? This one. When I multiply with the factors, I don't multiply by 365. So what is this now? Which VMT is this? Which VMT is this?
Each day.
An average day. Okay. It's an average daily BMT. Got it? Okay. Multiplying by 365, it becomes total. Without the factors, it will remain for that day. Okay. And without the factors, you cannot do this. If you don't multiply with the factors, it is not ADT. Then you cannot multiply by 365 as well. Okay. You can only multiply an average with the number. Okay. Not any value with the number. Clear or not? Any questions? Okay. The answers are given here. You can later on check. But you can see the values are calculated in the same way. You can see the where is the highest value? Tell me. Number 4. I should put commas here, right? It will become easier. I don't want to make it easier. So number 4 has the highest, right? Look at location number 4. Does it have the highest volume? Yes. Location number 4. Does it have the highest volume? Location number 4. Yes. It has the highest volume, right? Okay. And does it have the highest length? Yes. Okay. So that is what makes it most important. Okay. The most important highway. So it is serving more people and is covering more distance. Clear or not? Okay. Okay. We have talked about counting done on segments, counting done on intersections, counting done for networks. Okay. Now we are moving on to another type of counting, which is area based. Okay. Area or zonal counting. It's not counting actually. Counting is involved, but we are not interested in the count. I'm interested in the demand of that area. Okay. Whatever we are doing up till now, you are interested in the numbers which we have on the highway. Here it's not about the numbers which we have on the highway. Okay. Here it is about the number of people I can have from that area. Got it? Okay. So all these studies are trying to find out the demand of an area. They are trying to find out demand of an area. Okay. And there can be many of them. We are discussing the common ones, which is origin destination, screen line, and cordon counts. Okay, so we'll discuss 3 of them. The first and the last one are very similar to each other. Okay, origin destination and screen line are very similar to each other. Only the scale is different. And then we have the cordon counts. Origin means start. Right? Origin means start. And destination means end, right? Final destination. So here in this study, we are trying to find out how many trips start from an area and how many trips end at an area. Okay, start and end. There are 3 ways to collect the data, the accurate data of origin destination. One is using license plate studies. Okay, we discussed something similar for travel time as well. Okay, so you note down the license plate numbers of the cars which are passing. Where is your observation point? The entry and exit of the area. Okay, your observation point is the point from where the car can enter, the point from where the car can leave. Okay, and you are noting down what? License plate number. In the end, you will bring it to your office or whatever, and you will match. Okay, this license plate number was coming out of zone 2. Okay, and the same license plate number was going into zone 4. So zone 2 is the origin, zone 4 is the destination. Got it? Okay. Okay, another method is the postcard QR code, whatever you want to call it. Okay, like it's a very short survey. You give the users on a card or with a QR code or with a link, okay, which has like 3-4 questions. Origin of your trip, destination of your trip, the purpose of your trip, mainly purpose of your trip, and how did you make the trip? Okay, by car, by cycle, by walking, what? Okay. So postcard studies are short surveys. And those short surveys can have questions written on the card and you give it to the drivers and passengers. they will fill it and they will send it to you. Okay, but now we don't have to go into this fuss. You can just give them a card with a QR code. They will scan and just you will get the answers, right? Okay, so something similar. Then we have the interview studies where you take a full questionnaire, you go to the traveler and you do the full interview. Okay, so it has more questions. Okay, the earlier one is a short questionnaire, the next one is a very long questionnaire. So that long questionnaire is usually done with other studies. Okay, like the government is doing some metro, for example, planning for metro. Okay, so they will do an interview study. Okay, but that interview study will not have only origin destination. It may have income, family size, number of cars. So it will have more questions. Okay, which they will use in some other things. Okay, so interview studies are not done only for origin destination because it takes a lot of time. You have to go physically and you have to sit with them and so on. Okay, so in these three methods, you get the origin destination directly. Okay, I'm getting it. I'm asking you and you are telling me. Okay, or I'm observing in the field, this car came out of this area and went to this area. Okay, so I'm getting the origin destination direct. Okay, clear? But all these methods will only give you a sample. Any of these methods, okay, none of these methods can give you the total number of people coming and going. Agreed? Okay. Surveys, you cannot get 100% response. License plate number, you cannot take license plate numbers of all the cars which are passed. Okay, and so on. So these techniques need some counting in the field as well. Okay, but that counting is to support the sample which I already have. I already have a sample. I did one of these methods and I took a sample. Okay, now I'm doing a field study to support my sample. Got it? Okay, in that field study, we do what? We count total number of vehicles entering the area or the zone and leaving the area and the zone. I'm not interested in which segment they are passing, which intersection they are passing. Okay, and so on. I'm not interested in any of these things. Okay, how many cars entered, how many cars left? Only this. Clear? Okay. After that, we prepare this OD matrix. Okay, origin destination matrix. So in this example, I have 4 zones, 4 areas. So I'm interested in finding out how many cars enter these 4 and leave from these 4. Got it? I have collected a sample. These numbers are from my sample. So maybe let's say I did an interview. In my interview, there were 50 people who said our origin is zone 1 and our destination is also zone 1. Okay, so not going anywhere in their life. Okay, just remaining in their area. I have a friend like this in Karachi. His school was in the same area, university is in the same area, and he's working in the same university. So he's never left that area. Okay, so if you take him out of the area, he goes blind. That's true. Okay, 8 people said their origin is zone 2, their destination is zone 1. You understand? Okay. According to this table, total people in my sample who came out of area 1 are these 88. According to this sample. Okay. And number of people who went into area 1 according to my sample is 95. Okay. But these numbers are not full numbers. These are just samples. Okay. To get the full numbers, I went to the field and I counted how many cars are actually going into area 1. And I found how many? 250. Okay. So my sample shows only 95. My counting shows 250. You can see the big difference, right? There's a big difference. Same here. My sample shows 88 who originated from area 1. And my counting shows 1 and 10. Okay, so there's a big difference. Okay, So I need to increase my sample to match this, right? To match the actual counting. Okay. How do we do it? I'll go directly to the calculations. You can see the procedure over here. Okay, I'm just showing you the calculation. Okay. For each row and column, you will calculate the ratio of actual count upon total of the sample for each row and column. Okay. So for example, column 1, what is my actual count? 210. What is my sample total? 88. So the factor is 210 upon 88. Got it? Same thing with the row. Actual count 250. Sample total from the table 95. So the factor is 250 upon 95, 2.63. Okay. So in each row and each column, you have a factor. Okay. Now you take any number from this matrix. Okay. For example, we take the first number, which is 50, right? 50 means is the first column and the first row, right? 50 is in the first row and the first column. What is the factor for the first row? 2.63. What is the factor for the first column? 2.39. Okay. So I will adjust 50 by using the average of these two factors. So 50 multiplied by 2.63, 2.39 divided by 2. This will give me the adjusted number for this cell. Okay, people who are living in heaven. Zone 1, zone 1. Okay, and this number is how much? Oh my God, here the calculator. Yes, how much?
125.
0.25. Now you can see the change. It was 50. Was 50. Now it is 125. More than twice. Right? The change is 2 times and more. Got it? Okay. What will I do for the 10? $2.39, 2.92. Which is how much? If you keep on saying together, I will keep on saying yes, yes. He is spreading virus by saying 26, 26.5 only.
This is my answer, 27.
Uh,
I round the value up.
Very good. Okay, clear. Okay, this way we will adjust the entire matrix. Okay. This is the adjusted matrix, and this is how we did it. Okay, the procedure is already written there. Okay, so now you have a new matrix, right? All values are changed. None of the values same as before. Okay, so that means what? Total will also change. Each row and each column will have a new total, right? Will these numbers change? Actual counts from the field, they will not change. Okay, so now you can see I got, it was less than 100, now it is 232. It was also less than 100, now it is more than 200. Okay, and then you can see I keep on forgetting, but anyways, you can see the new factors as well, right? So these are the factors for each column, and these are the factors for like there should be some factors for each row as well. Where is it? And I bring it back. Yes. Okay, so you have the new factors. Okay, what are these factors supposed to be? How much should I get here? How much I'm looking for? 1, right? When you take the ratio of your sample and the actual count, they should become equal. If they are equal, then it should be 1. Did you get 1? No. Okay, so that means this trial is not final. We will do another trial. Okay. Now the rule is if your factors, all of them are between 1.9 and 1.1, all factors, all rows and all columns, 0.9 to 1.1. Okay, all factors to stop must be between 0.9 and 1.1. If one of the factors is out of this range, you need another trial. Okay, and the new trial will be with the new values. Okay, so for example, if I do another trial, then I will take the factor 0.9, 0.94 and I apply it to 125. Okay, I believe this was done here. It's not written, but how did I get 116? 125 multiplied by the average of 0.9 and 0.9. Why am I doing this? Because you look at these factors, you see this factor is out of my range. And you look at this factor, this one is out of my range. And this one is also out of my range. But I told you the rule, if it applies to only one value, the whole matrix will change. Okay, there will be a trial for the entire matrix. Got it? Clear? That's why we have so many parts for matrix, right? Okay. This is after the second trial. And these are the factors with the new values. Okay. Do I have any problem here? Yes. This one. That means what? Another trial. Okay. You cannot take this column out. You cannot take any row out. You cannot do partial trial. Okay. You cannot only do the trial on these values. No. The trial will be on the entire matrix. Okay. You will take the new values and the new factors and you multiply with the average. Got it? Any questions? Any problems? Should I stop here? Huh? If I finish. Okay. Clear? Okay. Thank you. Yes.
The mistake that all